This video is about the kernel selector, the switchless multi-kernel selector for the Commodore 64. And I will talk about the sleep function. So I've been playing around with the sleep function of this microcontroller. And first of all, I tried to wake it up with the Watchdog. So if you don't know what a Watchdog is, it's basically like it has its own timer. So if the processor stops for some reason, it can't push it back. So what the Watchdog does, it always moves to go towards the reset. So what you have to do is to push it back, and it will go towards the reset, push it back. So in here I have like a clear Watchdog at several places, but I have stopped using it because there's another way to wake up from sleep, and that is to actually listen to the buttons. Okay, so this is a bit complex, but please hang in there. So this is one of the pins of the microcontroller. It is fed into several places, and one of them is the read port, and the value is then stored such that it can be pushed out on the databus, so to CPU, so you can read. So you have a read signal, and here you can see you have something called interrupt on change. So if the pins changes voltage, it should then get an interrupt. And why do you have all this circuitry around here? Well, first of all, you have to mask it. That means you put there. You can see there's a interrupt on change enable. So if this one is set, then you have one of the AND inputs active, and then you has to be set as an input pin. So that's the 3CO, which also is in on that AND. And then to get an actual interrupt, both of these two has to be high, and the third one has to be high. And you can see this is a SOR gate, so if one of these two are different, or if these two are different, then you will get a high and you get an interrupt. So basically it looks for a change. So, and the way that works is that when you read the port, one of these is updated, and then when you stop reading it, the other one is updated. So yeah, so it's a bit difficult to explain, but you get a pulse out there. And I can tell you it wasn't that easy to get it implemented. So first of all, there's certain registers you have to set. I thought initially you had to set the global interrupt enable, but global interrupt enable is basically more like if you have an interrupt routine, you can have that serviced if you have that one active. But we don't want an interrupt routine. We just want this sleep function or the microcontroller to wake up from sleep. So you don't need that. So, and how? I just read on the net, and I couldn't find it in the datasheets. So typical. And then you have to set a register called interrupt on change, so you mask out those bits you want. So how do you test this? Before I show you how it works, I would just want to disable it. So what I can do then is to go in here and just disable all of this sleeping stuff. So like this, then run it. So what have I done? So now it's restarting here. You can see the LED is flashing, so that's indicating that it's in the loop. So it's toggling for every loop. So if I hold the button, and you can see it blinks faster, that indicates it's in another state. So now it's in the select state. So if I release it, then it goes back, but it doesn't go to sleep. So. But now we have an indication where in the state machine the code is. So if I now enable this sleep, and we also have to enable interrupts on the port, and of course mask those two inputs we want to listen to or get an interrupt from. So now we're programming again. There you can see the LED stopped, so it's in sleep now. So, and it wakes up, and release it, it sleeps again. So, and I haven't tried this many times. I'm hoping to find a bug or something, but and now when it's in this mode, it won't go to sleep. Only in the idle state. So, and also when you hold the button, the sleep function is not activated, because that was in the if statement I had. So, yep, so that works. So now I can put the microcontroller to sleep. Yes, so what does this sleep function do? It powers down the microcontroller, and it stops the oscillator, as you can see. As that means all the modules inside the microcontroller will also stop. And then when it wakes up, you can see that it has a time before the oscillator is stable. So, and that's about a millisecond, I think. So it's really fast, no problem. All this timing, the chip takes care of itself. So why do I want this anyway? I'm thinking, well, there's some things you want to avoid, maybe noise on the rails, like on the display. I haven't seen any yet, but anyway, when the oscillator stops, there will be no noise, and as you can see, even if it's in sleep mode, or hold on, there. So let's say I set into this kernel, which is the kernel selector. So if you haven't seen those videos, you can see it. Anyway, so I have selected kernel, now it's in sleep, it still holds the value on the port pin. So yeah, that's it. Thank you for watching.